to online physical science class for class 10. Today's topic electricity. Today's subtopic is Faraday's law of electromagnetic induction. Before we discuss the Faraday's law of electromagnetic induction, we have to know what is electromagnetic induction. Michael Faraday discovered that when a magnet is moved toward or away from a coil wound on a cardboard tube having galvanometer between its and a momentary current flow through the coil, that is an EMF, is induced in the coil and it lasts as long as there is a change in magnetic lines of force. This phenomenon is known as electromagnetic induction. Here I draw one picture over here. Coil is wounded over cardboard and connected with galvanometer. When magnet having in stationary position, that means it is not moving, no current is flow through this wire. So galvanometer is the indicator over here showing no current. As soon as we move the magnet toward the coil and away the coil very fast, we saw a deflection of indicator. We saw that current is producing. So how can we get the electricity from motion of magnet? We can show with a diagram. Whenever there is a relative motion between a coil and a magnet, an EMF is induced between the end of the coil, which give rise to an electric current called induced current. Now this electric current, which depends upon two factors. Number one, number of turns in the coil, that means more the number of turns, more will be the induced current. And second point is an area of cross section of the coil, that means more the number of lines of magnetic force flowing through this cross section, current will be more. Now here Faraday's laws of electromagnetic induction state that whenever there is a change in the magnetic lines of force linked with a coil, an EMF is induced in the coil as long as there is a change in the magnetic lines of force. The second law states that the magnitude of induced EMF is directly proportional to the rate of change of magnetic field links with the coil. That means E equal to N delta phi by delta T. Here E equal to induced voltage, N means number of turns, delta phi is a small change in the flux inside the coil, and delta t represent a small time interval during which the flux change. Thank you very much.